So good afternoon everybody, myself Acharya Vishvendra, and today I shall be speaking on elastic potential energy density. As you can see in the question over here that if we compress a spring, then on releasing it can give kinetic energy, as in this stretched bow with an arrow concept, or in this game. So when you stretch a certain material, then potential energy gets stored in that stretching, and that can be transferred to something in terms of kinetic energy. So let's see some questions on this. Let's start. So the topic over here is worksheet on elastic potential energy density. The first question is dimension of this. So the dimension is m1 l minus 1 t minus 2. Then we need to find SI unit of energy density. It is Newton per meter square. Then CGS unit, it is Newton per centimeter square. Then energy density, it is half into stress into strain. Another formula is half y into strain square. Another is stress square by 2y. Then we have E versus stress graph. So if strain is constant, E is proportional to stress, so graph will be a straight line. Tan theta is E by stress. So after calculations, it comes out to be strain by 2. Next one, now we have E versus stress square when stress graph when y is constant. So the relation here is stress square by 2y. So it is proportional to stress square, graph will be a parabola. Then if y is constant, E proportional to stress square, I assume that stress square is equal to x. So we have the relation E proportional to x, graph will be a straight line. Then we have if stress is constant, then E is proportional to strain. So if we draw graph between E and strain, that will again be a straight line, and tan theta is equal to stress by 2. Next is graph between E and strain when y is constant. Y is the Young's modulus. So relation is this. So E proportional to strain square, graph will be a parabola. Then we have strain constant, graph between E and y. So relation will be half y strain square. So E proportional to y, that means graph will be again a straight line. Next is E versus y graph when stress is constant. So we know the formula will be stress square by 2y. So E proportional to 1 by y, graph will be rectangular hyperbola. In the next question, we have E versus 1 by y. So we take 1 by y as x. So we can say that it is proportional to x when stress is constant. So graph will be a straight line. Next is we need to draw a graph between E and 1 by y when strain is constant. So relation will be this. So we assume that 1 by y is equal to x. That means y is equal to 1 by x. So we can say that E proportional to 1 by x or proportional to 1 by x. So here consider 1 by y as x. We can say that there is inverse relation, graph will be rectangular hyperbola. Next we have graph between E and 1 by stress when strain is constant. So relation is gonna be this. So E proportional to 1 by x, graph again will be a rectangular hyperbola also here. Next is we have E versus 1 by strain. So E proportional to 1 by strain if y is constant. So next one, now we have stress as constant. So E will be proportional to strain, or it can be written as 1 upon 1 by strain. So we can say that E proportional to 1 by x, graph again will be a rectangular hyperbola. If we make here 1 by strain square, so we can say that 1 by strain square is x, so 1 by strain will be root x. So strain is 1 by root x, E proportional to strain, so it is proportional to 1 by root x. So the graph again will be a rectangular hyperbola as given in this. So I hope this will optimize your time and energy and prepare you help in preparing the NEET and JEE in physics. Thank you and have a nice day.